Hello, my name's Shane Fowler and I'm a systems engineer in VMware's End User Computing business unit, and welcome to my video entitled From Zero to Hero, How to Deploy the Horizon Cloud Service on Azure. And over the next 60 minutes, I'm going to show you how to do exactly that. A typical customer deployment can take anywhere from half a day to a few days, but it depends heavily on the complexity of their networking requirements as well as how much customization their base operating system images require. There are a few things, however, that I don't cover in this video. The first is Dynamic Environment Manager, which is VMware's tool for handling user profiles and user personalization within your desktops. I would strongly recommend that you go and take a look at it because it makes that an absolute breeze. The second is how to integrate Workspace ONE access into your Horizon deployment. And this is VMware's recommended way of either aggregating multiple Horizon pods together into a unified portal for access, as well as a way to more seamlessly integrate multi-factor authentication and conditional access. So take a look at that too. At the end of this video, I'll put some links to some of that content as well as where to download tools like OpenSSL, which I use for some of the certificate work during the video. Anyway, let's jump in. So before we start, I wanted to take you through the architecture of what we're about to deploy, which is a full Horizon pod in a single Azure subscription. And this could be scaled up to anywhere up to 2,000 concurrent users. The green boxes indicate things that we need to go and deploy, being the actual end user, and the blue boxes are what the Horizon Cloud control plane will go and deploy using its automation. It's also worth pointing out that a single pod can service 2,000 concurrent user sessions or 2,000 virtual machines. You can have multiple pods to scale well beyond 2,000 users if you wish. I also wanted to call out something specific about the DNS connection you see in the diagram in front of you. That's a logical flow. The actual physical flow is via the VNet to on-prem via the IPsec VPN connection. I've made the assumption with this video that we're starting from stone cold nothing. So what you'll see is a series of diagrams at the start of each of the sections, which show which components of that architecture we're building. And we're literally starting from scratch, as what you see on the screen would indicate. So the first thing you need to do is register with the Microsoft Azure portal and sign into it. Then once we've done that, we can go to the subscription section and click add to add a subscription. So this is where we select the type of subscription. I'm going to pick pay as you go, but if you were deploying a non-production environment, you could choose a developer type subscription. You now fill out your personal information as far as who you are and your contact information. You will be required to verify your mobile number. Because it's a pay-as-you-go subscription, I need to provide some credit card details. I've edited it out of the video for privacy reasons, however. Now, this is where you choose the level of support that you get for your environment. For a production deployment, I'd strongly recommend that you choose production use of Azure or above, but because I'm just doing this for a demo video, I'm choosing to not add support. And then you need to agree to the terms and conditions and click sign up. So before we delve into how to create VNet specifically, I wanted to briefly touch on what a VNet is in Microsoft's hub and spoke architecture. A VNet is a logical networking construct within Azure, and the hub and spoke architecture is where we create a series of VNets, one being a hub where we have all of our resources that we want to share, typically infrastructure virtual machines like directory services servers or file servers, and then other networking resources we want to share like express route gateways or virtual network gateways, which are used for creating IPsec connections to things like on-premises infrastructure, for example. And then you would peer that with other networks which want to share those resources, like the one we're going to create shortly for our Horizon infrastructure to reside. So to create our first VNet, we need to go into the Azure portal and go down to Virtual Networks. We then click the Add button. And the first thing we need to define is the resource group we're going to deploy into. A resource group is a logical collection of Azure resources such as virtual machines, storage accounts, and networks. So we give it a name here. We need to create a new one because we didn't have one already. Now we need to name the VNet itself, which we give a name here. Now we need to choose the region we're going to deploy into, which is Australia East in my circumstance. Now we need to define the address range of the virtual network itself. Now, the overall address space needs to be at least a /22 because we're going to create a minimum of 4 subnets underneath. Now, you do need to take into account the address range space, how many virtual machines you're going to deploy. So I've used a /22 here, which gives me 3 networks underneath, which have 251 usable addresses because Azure uses up some of them for internal purposes. So if you're going to deploy a fully deployed pod of 2,000 virtual machines, that network's going to need to be a lot larger. And we do need to create an initial subnet as well. So I'm just going to create one here, which is a /24. So in line with our hub and spoke architecture, the next step is to create the hub network, which is where we're going to plumb in our VPN connection through to our on-premises data center. So we're going to go and create that now. So now we need to define an address space. Now I'd recommend using at least a /23 because we need to create one VNet as part of this process, and the virtual network gateway we're going to build later on will create a subnet of its own. So I'm going to deploy a single subnet here, which is a Class C network or a /24 of 251 usable addresses for infrastructure. Then click Next. Go to the end where it reviews the configuration similar to how it did before. Click Create and it submits the job. So the next thing we're going to go and create is the VPN gateway within the hub virtual network. So we need to go to Virtual Network Gateways within the Azure console and click Add. Now we need to give this a name. We then need to define the virtual network it's going to get deployed into, which is our infrastructure VNet. And we need to give it a subnet address range. So this is for the subnet that it's going to create, not the one we created earlier. And give a name to the public IP address, which is going to be bound to the virtual network gateway. We then go to the end to review and create. Again, some more checks and balances. Once it's validated, we click Create and it gets submitted as a job for deployment. The next step is to define our local network gateway, and this is a definition inside Azure for what Azure can expect on the other side of the divide as far as the local on-prem data center is concerned. Things like which subnets are across the other side so it can create the appropriate routes. So to do this, we go into local network gateways within the Azure console and click Add. So we need to give it a name, so I'm going to call it Site-to-Site VPN. Need to give it an IP address. This IP address is the public-facing IP of where the VPN connection is going to be terminated in your on-prem data center. And we need to define the address spaces of the networks that Azure can expect to find on the other side. We then submit the job for deployment. So the next thing we're going to do is create a VNet peer between the two virtual networks that we've defined earlier. And what this does is allows traffic to flow between those two networks. So in order to do that, we go into the Azure console, go to virtual networks, find our infrastructure network, go to peerings, click Add. We need to give the peering a name, so I'm going to call it Infra to HSOA. We need to pick the network we're peering with. We then need to give a name to the peering that gets created in reverse. We need to enable forwarded traffic, and we need to allow traffic from a gateway to traverse that peer as well. And that sets up the networking flows to allow traffic to go all the way from on-prem through our transit VNet through to the VNet where our Horizon deployment is going to live. The next step is to define the VPN configuration. And what this does is defines the connection between the VPN gateway and the local network gateway, effectively the configuration of the IPsec tunnel that we're going to create for the VPN. So we go into our virtual network gateway, we go to connections and click Add. We need to give it a name. It's a site-to-site VPN. We need to choose the local network gateway we defined earlier, and now we need to enter a pre-shared key. This is used to secure communication between both ends. Double check we're deploying the correct resource group and click Create. The next step is to then go and get the configuration out that we need to go and put on our on-prem router or firewall where the VPN is going to be connected the other end. Now I'm going to use a generic sample here because it gives us some Cisco commands that we can have a look at for what the definition is, but you could choose your relevant vendor from that list. This is where we get the public IP address. The networks within Azure, we can double check that the peering's taken place and the right networks are present. The on-prem IP as well as the cipher. So about 10 minutes after that's all defined, we should start to see the connection status reflect in the console. We should be able to see that it's connected and data's gone over the link, hopefully. So the next step is to change the DNS server settings for both of our VNets to point to a DNS server that's linked to your Active Directory domain. Next step is to configure DNS on the virtual networks. So I'm pointing this to my on-premises DNS server. So the next step is to create a service principal in Azure that has contributor level access to your subscription, which we then give to our Horizon Cloud control plane. Now, the reason the control plane has this level of access is this is how we can do all the automated deployments. This is how it interfaces to your Azure subscription to do all the operations it needs to. Everything from updating the software, maintaining the environment, and all of the operations around your virtual machine provisioning. So we need to search for Azure Active Directory. And then go into app registrations. We then need to click register an application and give this application a name. So I'm going to call it the Horizon Service on Azure. Take note of what you call it because we'll have to search for it later on. Then click register. It can take about 10 minutes for the registration to complete. Now you want to note down this application directory and object ID and copy that to Notepad somewhere because we're going to need that later on. So we now go to certificates and secrets, click create a new client secret, set it to never expire, and give it a name. Now, make sure you copy this out as well, because if you navigate away from this page, it hides that key and you can never view it again and you'll have to delete and recreate later. So I'm going to open Notepad and copy that out now. I'm now going to go into my subscription under access control and grant this rights. It needs to be contributor level access, and we now search for the name of the application as we defined earlier and click save. Now the last thing we need to do is make sure that the correct resource providers have been registered on our subscription. So I'm going to show you here how to register the insights by searching for it and clicking register. You'll be able to see a list on your screen now for all the others that you will need to go and check one by one and do the same. So the next step is to ensure we have enough quota or capacity within our Azure subscription to service all of the workloads we're going to deploy. So let me show you how to go and request an increase. You go into subscriptions, choose your subscription and go down to usage and quotas. Now you can check what allocation you currently have by going to choose a service provider, which is Microsoft.compute, and choose the region that you want to deploy your pod into. In my case, it's Australia East. And from here, you can see what current usage there is, if any. So I'm going to go and request an increase. We need to select the quota type that we're making this request for. Because we're wanting an increase of vCPUs, we choose Compute VM Cores and vCPUs and choose Next. The first thing we need to do is provide details of the request, which includes which region we're making the request for. So I'm going to deploy into Australia East, and then which virtual machine types. So we need AV2 series virtual machines, which are used for our unified access gateways. They can also be used for lower cost virtual desktops. DV2 series, which are used for our base images. DV3 series, which is the recommended type for desktop workloads. Potentially EV3 series virtual machines, which are used for RDSH, which are for session-based desktops or borderless applications potentially. You may want to choose NV series virtual machines, which include a NVIDIA GPU for 3D workloads. They can be used for both RDSH farms and desktops as well. And the F series, which is used for our jump host, which is a virtual machine which is deployed temporarily during deployment, as well as maintenance operations like upgrading a pod to a newer version of the software. So 10 for the F series is enough, so I'm going to remove that here. The DV2 series is used for our base images. They require 4 vCPUs. I'm not going to have any more than 5 images powered on at once doing software updates, so I'm quite happy to leave that at the number that it is. If it's less than 20, you may want to consider increasing that. I'm going to remove that from my request though, because I don't need any more. And the remaining types we actually need to do some math around. So the first being the AV2, which is used for our UAGs. So if you're deploying either an internal or external UAG set, they're actually deployed in highly available pairs and use 4 vCPUs per virtual machine. So if you have both an internal and an external set, there's 4 of them, which means you need 16 vCPUs. But it doesn't stop there. We also perform maintenance of our pods using a blue-green model. What that means is that we deploy a fresh set of infrastructure alongside the current deployed versions using the new versions of the software. We then configure those, add them into service workload, and then remove the older ones from the load balancers to no longer service workload and decommission them. So what this means is, in order to enable enough capacity for maintenance operations, we actually need to double that again to 32 as a minimum. Now, the DV series virtual machines are the ones which are used for the Smartnodes, as well as the recommended type for desktop workloads. To start off with, we need to have a look at how we've actually chosen to deploy. So you've either chosen to deploy in HA or non-HA mode. So that means you've either got 1 or 2 Smartnodes at 4 vCPUs each, which means if you're in HA, you'll need a total of 8. Now, because of the blue-green upgrade method, we also need to double that again to a minimum of 16. So that being said, we're also going to deploy desktops on top of that. So we need to look at how many desktops we're going to deploy, what that workload is, and what the CPU allocation should be, as well as a buffer for maintenance and provisioning operations on top. I personally recommend no less than 2 vCPUs for a Windows 10 virtual machine, but that should only be for a task worker. And if you've got a knowledge worker or any desktop workload that has any form of multimedia, i.e. video or voice, say Skype for Business, for example, you'd want to start with a minimum of 4 vCPUs. You then need to multiply that by the amount of desktops you're going to deploy. So in my scenario, I'm going to deploy 10, which is another 40 vCPUs. Then you need to add a buffer for maintenance operations as far as new desktops, how many desktops you're provisioning at once in the background. For example, when you're deploying a new base operating system image. So I typically allow a minimum of 10%, but you'll need to have a look at how large your desktop pools are going to be and how long it takes for that provisioning process to go through. So you may want to request more. So to do the math, we need 16 for our smart host. We need 40 to service my desktop workloads, and we need 4 vCPUs for that one virtual machine during provisioning operations. So that brings our grand total up to 60. We click Save and Continue. I'm going to choose to contact me via email and click Review and Create. Double check the numbers you've got here, click Create, and it will submit your support request. So one of the most common queries we get from customers deploying the Horizon Cloud service on Azure is how to get their certificates into the correct format to import both into the UAGs and into the Smartnode. And you actually need 2 different formats. So I'm going to show you the process that I've come up with, which is the easiest way to ensure that you get the certificates in the right format. So first things first is typically most certificate authorities will let you export something in a PFX format. That's what I'm going to start with. Now I've downloaded a version of OpenSSL, which I'm going to run a series of commands to convert this PFX into a number of files that we need to assemble. The first command that we need to execute is one that generates the client certificate. pkcs12-in, the PFX file name, no keys, which means we're not generating any private keys, CL certs, which generates the client cert only, and then the out file. And then we give it a name with a .crt extension. We run this, we enter in our password for the PFX, and it'll then export that certificate. So the next thing we need to do is generate the private key that accompanies that certificate. And we do that with this command. So OpenSSL pkcs12-in, the name of the PFX file, -nodes, -no cert, so we're not exporting the certificates, so we'll just get a key, -out, and then the actual file name we want to export the key to. We get prompted for the password again. Now we've exported the private key of that certificate. So the next piece of the puzzle is we need to export both the intermediate and root CA certificates and then merge them together into a PEM file. The easiest way I found to do that is to actually open the client certificate, go to the certification path, and then open each one of these one by one. So if we view this certificate and go to details, we can actually copy to file. Now we need to choose a base64 encoded format, and we specify our file name. We want this to have a .crt extension. And now that's been exported. And then the final file to export the root CA, the file. So now what we need to do is just take that extra file extension off the end. Now what we need to do is actually create a PEM file. I'll create a text file, call this. So this is where we aggregate together all of this key material. So if we open this PEM file, we want to import all of the certificates in this order. So as we go through, I'm going to open up the actual client certificate, open it in Notepad. I'm then going to copy the key material out and replace that here. I'm then going to open the intermediate certificate. Copy that content where the intermediate CA goes. I'm going to open the root CA cert. Then I'm going to open the private key. Need to make sure it's in RSA format as well, because if it's not in RSA format, there's an additional command you need to convert it. Save that and close. So now that that's complete, the only other thing that we need to do is to open the root CA. And append this to the end of the intermediate. And now delete this root CA certificate. So what we're left with at the end of this process is 4 files that we've generated. The PEM file is used for importation into the unified access gateways, either the internal or external set that you deploy. And because it's in a single file, it contains the client certificate, any intermediary certificates, the certificate for the root certification authority, which the certificate's been issued from, as well as the private key for the client key. The other 3 files are what we import onto the pod, and then used for the internal connections that don't go via UAGs. First CRT file includes the client certificate only. We've then got the key file, which is the accompanying private key, and then we've got the remaining file, which includes the certificates for both any intermediaries and the root certification authority. So now we're at the point where we've done all our prerequisites, we've created our service principal, and now we can use that service principal to, via the Horizon Cloud Control Plane, deploy all of our pod infrastructure. So if we log into cloud.horizon.vmware.com, we log in with our My VMware account that we've registered. If we haven't logged in before, we may get asked to accept some terms and conditions, which I won't get prompted for because I did it earlier. I'm going to go and click Add to add my cloud capacity. I'm going to choose Microsoft Azure. And then this is where we normally go and fill out the details of our subscription. Now, remember earlier all of the these goods and things I pointed out that we needed to save? This is where we need them for, including this key, which you can't go back and get out of the console. If you forgot to get this earlier, you'll have to go back and recreate that key. So we now go and cut and paste all this into here, but because I'd done this earlier, it's all defined and I can choose it here. Now I give my pod a name. It's going to call this Pod 1 Australia East. Give it a location. It's based in Sydney. I'm going to choose to deploy it in Australia East. Setting the high availability option makes the control plane deploy 2 load balanced and highly available smart nodes. Turning this on is recommended for production deployments, but I'm choosing to not enable this as I'm just deploying a lab environment for demo purposes. This is where we define our networking, so we choose our subnet that we created earlier. This is where we define our IP ranges. So 101 for management, 102 for desktops. We need to define a NTP server, so I'm just going to use a public one. We can potentially define a proxy, but we won't here. So we will click next. This is where if we want external access, we can define the configuration for a unified access gateway or a UAG. So I'm going to go and put that in now. Can specify some DNS details here if I want it to be different from what's on the Azure network, and I'm going to upload my wildcard certificate here. It's got to be in PEM format, it's very important. So here's where we choose the type of load balancer that gets deployed. We have 2 options, basic and standard. The primary difference between the two is a standard comes with a 3 nines SLA, whereas a basic does not. So I'd strongly recommend that you use a standard load balancer for production deployments. If we wanted to use a different network, we could use that here, but we're going to get this to create one for me. 24. If we wanted to enable 2-factor authentication, we could. We could actually pick to add a radius server and put the details in. Or alternatively, if we wanted to create an internal UAG set, we could do that as well, but we're going to not do that here. So now we click validate and proceed, and it will double check the settings that we've put in are valid. And then from here, we double check that what we've put in, there's no typos. 102, 101 for management. Certificate, that's correct. DMZ, now we click submit. So now we're complete. We're about an hour from start to finish, and we've now got our complete pod. So if we go and have a look, we've got our 2 UAGs, our Smartnode and our jump box is now fully provisioned. So a quick note around what some of our customers are reporting is happening when they're deploying into Azure regions which are under high load. We've actually noticed that some deployments are timing out because when they're trying to deploy too much at once. So I'd recommend that if you get something similar to the error that you currently see on your screen, look at deploying a pod in either non-HA mode or not deploy the UAGs up front and then come back and deploy them later on. So now that our first pod has been built, so it's taken about an hour, we can now jump in and start configuring it. So the first step in that process is to integrate with Active Directory. So we go down to our general setup, choose Active Directory and press configure. Now we need to specify some details around the domain, which I'm now going to enter here. So this will obviously be relevant to your domain, and then you need to create 2 service accounts. So in the install documentation, it details what rights they need, and mine are HDB1. I've pre-created these service accounts. Now, if your DNS is configured and your network flows are set up correctly, we should be able to bind to the domain. So this is going from the Smartnode and then connecting to Active Directory. So now we enter our details in around our domain join. I don't have a secondary DNS server, but now I enter put in the details for my domain join account. So I have created a second account, which I've put the details in here, and I will click Save. Now I need to add an administrators group. I've pre-created these groups in my Active Directory, so I'm going to choose my Horizon service on Azure Admins group and click Save. So now what we need to do is re-authenticate. So I'll put in details for our account. And now we need to log on with some domain credentials as a second check to authenticate through to the domain services. That's how we get our role-based access into the cloud platform. So we can now elect to join the customer experience program. I'm going to do. And now our general setup is complete. So we've now got our Active Directory set up, our roles and permissions are set, and our cloud monitoring service is enabled. The next step is to upload our certificates to our pod, which will then be deployed onto our Smartnode by the control plane. So we do that by going into Settings, going to Capacity, viewing our pod, and we can actually upload pod certificates. We go in here and upload our CA certificate, which needs to be in CER format. So that's it here. We'll upload our actual certificate itself, and then the key in these are all in .der format, and click Save. So this takes about 10 minutes to process. So in 10 minutes time, the screen will refresh and we'll be able to log back into the console. So if we drop back into our console, the other thing we need to look at is setting our internal DNS. So there's 2 IP addresses that we need to set. So one is the internal IP, which is actually used for clients which are on the network to hit this Horizon tenant, and that's this tenant IP address. So that IP address is what we need to set for our internal DNS entry to point to the Horizon environment or the Horizon pod. Now, we also need to set our external DNS for users which are coming in over the internet. So if we actually scroll down, that's where we get to our external UAGs, and this is our external facing IP address here. So now that that's done, the other thing we need to do is look at our user experience under general settings. So in the general settings, this is where we set our contacts, what the default domain is, some session timeout parameters, which we can edit here around idle times, how long to broker, etc. We can set some settings around cleaning up credentials, the default message around your RDSH farms. The important one I want to draw your attention to is this one here. So at the moment, if we try and go to the Horizon pod, we actually get this default domain. Now, if you've only got one domain, you may want to turn that off. So the way that's done is by going back here into the domain settings, turning off the default domain and hiding the domain field, which I'll now set. Now that setting takes a couple of minutes to propagate through. We also want to turn on the monitoring service here if it's not on already, which is what we do around performance analytics, which we'll get into in a little bit more detail in a future session. So other things you may want to look at while you're here is roles and permissions. So this is where we can actually define role-based access based off of your Active Directory accounts, as well as under the VM types and sizes. So at the moment, all of these virtual machine types are available in my region, but I may want to, from an administrator standpoint, remove access to certain types of virtual machines. So there's 196 different types in this region. But if I wanted to create tags for certain ones, for example, I could go back in here and set those. We're now at a point where we can import our base images, which we'll use for our desktop deployments, and customize them. Go to our imported virtual machines and go and import a new base image. You've got an option to upload your own, but I'm going to choose from the marketplace because we then get a Azure optimized virtual machine. So we go in here and choose our operating system type. I'm going to choose to domain join this machine. I'm going to enable a public IP address for remote access. I'm going to create a local administrator account to log into the machine. I'm going to choose this and I'm going to give it a name. So this will be Win 10 1909 version 1. Now under the advanced options, we can also go in here and choose which parts of the Horizon agent are installed. I'm just going to go through and I'm going to enable all of these features and choose import. So now we need to wait for this to complete. If we have a look at our alerts, this virtual machine was ready in about 18 minutes, which is a fairly long period of time. So I think our Azure region's under a bit of load, but we're now at the point where status is green and we'll be able to log in and start customizing. So let's go to the virtual machine inside the Azure console. This is it here. And we'll be able to connect to it using RDP because we use this external address. We could connect using an internal address if we were on the internal network. Let's connect in. I'll now authenticate in. We'll be able to install some software and then convert this virtual machine into an image, which we can then use to template out some desktops. So it's the first time we've logged into this virtual machine, so you can customize these. We're just going to accept the defaults. And here we are. So let's go and connect in to now put in some credentials. We'll install Firefox. Install 7-zip as well. Okay, so they're all now installed. So 7-zip, Firefox, and Notepad++. So now we will sign out and go back into our console. The next thing we can do is actually convert this into an image. So once that's an image, we can then use it to deploy desktops. Because this is a fresh image, what this is now going to do is go and register the agent with our Smartnode for importation. So this can take anywhere up to 10 minutes. Okay, so our agent's now active. So now we can put in our company name, admin password again for that local administrator account, and we click publish. So now this virtual machine is in the process of being converted. So you'll notice it's missing. So if we actually go across and look in our images, here it is, and it's in transition. So after a few minutes, the actual status has changed to published. Now that we've imported and customized our base image, we're at a point where we can create our first desktop assignment. So we can create desktops or application pools. So what we're going to do here is create a desktop. We have the choice of creating either a dedicated or floating desktop. For this particular use case, I'm going to create a persistent-like desktop. So I'm going to create dedicated. I'm going to deploy it in my pod. I'm going to do a 2 CPU'd 8 gig of RAM. I want it to perform a little bit better, so I'm going to give it a solid-state drive. Choose the domain for it to join. I can turn on disk encryption. I'm going to give this a name, desktop. Default protocol is going to be Blast. I'm going to choose to use a browser by default. About one desktop, power off protection time, choose my licensing. I can define a particular OU for the desktop to be provisioned in, and I can set some timeout intervals and some Azure tags as well. I'll leave those at the defaults. The current QSing desktops, this is where we can actually enter the amount of desktops that can be concurrently QS'd during imaging update operations. So we'll leave that at the default with 1. We can log off disconnected sessions after either immediately or a timeout after a number of minutes, but we'll leave that turned off. Max session lifetime as well. We do have the capability to actually schedule power management. So what this gives us the ability to do is set up a schedule for specific days of the week where, for example, between 9 a.m. and say 6 p.m. at night, we can actually set a minimum amount of desktops that will be powered on. So this gives us the capability to force on a larger number of desktops during peak hours so they're ready to service workload. But I'm not going to define that here. I'm just going to leave the defaults. I now can search for user groups. I'm actually going to search Active Directory, go and pick my users group that I've already got predefined, being the users that are entitled to use this assignment. So there's our definition. We can double check to make sure we've got everything set correctly. It's all correct. We hit submit. The platform just does a few validation checks. The job gets submitted. Now the control plane is going to go through and contact Azure and start templating out those virtual machines. Now, if we do want to check on progress, we can click on the assignment, and under System Activity, we'll be able to view the action that's currently being taken by the control plane, which is expansion. If we drill down, we'll be able to see that it's still cloning that virtual machine and preparing it. Now that we've completed our desktop assignment, we're at a point where we can finally log into a desktop and see what it can do. All right, so that's now completed. So we should be able to try and log into that desktop. I'm now going to log in with my details. Because we set it to 0 available desktops, it's actually going to now go and power on that desktop. So that's why we've been given this message. So here we are logging into our desktop for the first time. So because we haven't set up any profile management yet, this is going to go through a normal profile build out for the first time. And here we are with our fresh provisioned desktop, and the applications that we installed earlier are present. The next thing I wanted to show you was the Horizon control plane and what performance metrics we can get out of it. So here I've got a desktop session that's running, I've got a video playing, and we're UDP connected because we're external. We've got 1 meg of traffic and we're pumping out 25 frames a second or thereabouts out of this desktop. I'll leave that running in the background and we'll log into our console. What I can actually do is search for a particular user. From here, I'll be able to see how many sessions as well as which desktops and which assignments they're assigned to. Now, if I drill down into that desktop, I can send the user a message, reboot the machine, I can force log on or reset, disconnect. I can even drill down into the processes which are actually running. For example, I can actually see what's generating load in the machine. I can also go through and have a look at the different stats, like for example, which gateway I'm connected through, so whether or not I'm internal or external, how long I was logged on for, as well as some user experience metrics. So what the current frame rate is, the amount of bandwidth that's being consumed, as well as the estimated bandwidth, any packet loss that's experienced, as well as real-time performance metrics so that we can actually see if there's been any latency spikes, any performance issues with the desktop. And without needing to remote control the machine, I can actually go in here and remotely kill processes if I need to. You'll notice in the background that that browser session's been terminated. So if I go back in here and actually refresh my performance metrics, it actually updates relatively quickly with what's actually going on in the background. I want to get details around where my sessions are, how many active versus idle connections, as well as the client types, a bird's eye view from the front dashboard. And with that, it brings us to the end of our video. So by the end, you should now see the process from start to finish of how to deploy the Horizon Cloud Service on Azure, one pod into your Azure tenancy and be able to connect to it externally. Hopefully you found it interesting. So the last thing to point you at is a series of useful links. The first set are from VMware. The first link out of the gate, which is something I use practically every day, is TechZone. It has everything technical regarding VMware's end-user computing products. Reference architectures, operational guides, tutorials. There's a ton of content on there. Please go and check it out. The second link is where to go to in order to sign up for a 45-day trial of the Horizon Cloud Service on Azure. It takes a couple of days for someone to get back to you via that link, so if you need something sooner than that, I'd recommend reaching out to your local VMware representative and they should be able to expedite that for you. The last two links are around something I promised at the start of the video. So where to go to around a guide for how to integrate Workspace ONE Access with your Horizon Cloud Service on Azure. Check that out. And also the documentation around how to deploy Dynamic Environment Manager. Believe it or not, the actual agent is installed as part of the image build process automatically. So all you have to do is set up a file share and some config files and you're literally right to go. So go and check that out. Across to some other links. So there's a link there to the version of OpenSSL, which I use to do the conversion of certificates in the certificate section. So have a look at that. There's a link to the Microsoft Azure pricing calculator, so you can use that to do some sums around how much your Azure capacity is going to cost you, as well as a subnet calculator I use for figuring out all of the subnets and subnet masks and things like that you saw throughout the video. And then last but not least, how to connect with me. So I'm launching a blog soon. Please have a look at that. There's my LinkedIn address as well as my Twitter handle. So with that, that's all from me. Hopefully you enjoyed the video, and we'll see you next time.